Alright, today we're graphing inequalities, and first of all, we're doing it in two variables. Then when we get to the next page, we'll do them in one variable. But two variables, you'll see in this inequality here, you've got both some x's and some y's, and we're graphing inequalities, not equations. Notice they're not an equal sign here. So, same thing as before when you're graphing a parabola. You want to know where the vertex is. Well, this inequality is in standard form, ax squared plus bx plus c. So for me to find the vertex, the x value of the vertex, again, is the opposite of b over 2 times a. We're going to do this first before we punch it into our calculator. So it is the opposite of b, so that'd be negative 6 over 2 times a, which is 2. And that gives me 3 for the x value of the vertex. In my table of values right here, I will put an asterisk next to my vertex. Then I will let my calculator do all the rest for me. So go ahead and type this in, x squared plus 6x plus 7, and then go to second table and just hover around where 3, since 3 is our vertex, I want to have that in the middle. And no wonder why I made such a mistake, because it's negative 3, not positive 3. I was just wondering. That's why I hit pause there. But negative 3, my bad, is the x value of our vertex. Should fit on our graph nice and neat. I mean, when they give us a scale going by 10. So negative 3, my bad. Negative 2 is the y value of that. Then we hover around, get 3 bigger and 3 smaller. And we will copy them in to negative 1. Negative 1 should be symmetry around this bad boy. And then when we graph this, this is a little different though, because it's an inequality. So we're going to plot the points. I like to start with the vertex first. Negative 3, negative 2. There's my vertex. Then plotting the other points. Negative 2, negative 1. And symmetry around him. Negative 1, 2. And then he pops over here. 0, 7. There's our y-intercept. Symmetry around this. But now, it's just like when you graph linear inequalities, you had to use either a solid line or a dashed line. Well, same concept here. Since I don't have an equal to bar on this, I do not want to connect these together with a solid curve. I want to use a dashed curve, meaning any ordered pair actually on this parabola does not satisfy this inequality. So, making it dashed. Then, if y is all by itself, you can use the symbol to tell you where to shade. The symbol is greater than, so go to the vertex, and greater than means like above that, so you'll shade above that, which gives you inside the parabola. So, shading inside. Again, this trick only works when y is all by itself, but y was all by itself. So any ordered pair in this shaded region satisfies this inequality. If you are actually on the parabola, it wouldn't satisfy because that's where you're equal to, and this doesn't have an equal to bar. So we'll do that again with this bad boy. First we'll find the vertex. This is in standard form, so the x value of the vertex is going to be the opposite of b over 2 times a. This is such a handy formula. That's why I like to write it down over and over and over again. And this time I'll do my mental math right and get a 2 for the x value of the vertex. Then we'll punch that in our calculator and fill out the rest of the table. Here she is in my calculator. I'm going to use the table and just center my table around 2, since I know that's the vertex, and it should be symmetrical on both sides. If I go one more, which that is, the y value of the vertex is at negative 2, and then I'm going to go 3, 4, 5, and 1, 0, negative 1. That would give me a negative 11, a negative 6, a negative 3, and the symmetry happens around that. And now I will plot those points. So 2, negative 2 is my vertex. 3, negative 3. You can see that this bad boy should be opening down, right? Hence the a value. So makes sense that that was a maximum. 4, negative 6, and 0, negative 6. There's our y-intercept. And 5, negative 11. I'll go ahead and put that. It's pretty close. Negative 1, negative 11. Solid or dashed? Since this is an inequality, we're going dashed. And where to shade? Since y is all by itself, you read the symbol, go to the vertex and go less than that, and you're shading inside the parabola again, right here. Any ordered pair in this shaded region will satisfy this inequality. So, pretty piece of cake, just graphing as we did before. And now we just got to do the solid or dashed and where to shade. So, let's find the x value of the vertex here. This is in standard form. If it was in vertex form, then we'd know where the vertex is right away. But it's not. It's in standard form. So opposite of b over 2 times a. There's my negative 3 again. Punch this puppy in. Got her punched in. Table of values. Negative 3 should have some symmetry around him, which it does. So star, negative 3, and negative 5. Negative 2, negative 1, 0, negative 4, negative 5, negative 6, 4, negative 1, negative 4, negative 4, negative 1, 4. Plotting. Switch colors. I like to switch colors. This parabola should open up. Negative 2, negative 4, Boutros, Boutros. Negative 1, negative 1. Boom, boom, and 0, 4. Solid parabola this time because there's an equal to bar, meaning this actually counts. And greater than, so that means go to the vertex and go greater than that, and you'll shade on the inside of that puppy. One more, baby. So, finding the vertex again, this is in standard form. If it was in vertex form, you should be able to read it and see where the vertex is. So opposite of e over 2 times a. That gives me a negative Juan. Punch that puppy in. Negative 2x squared minus 4x plus 2. Table it up. Negative 1 should have symmetry around it. If it doesn't, then you made some sort of error, which, as you saw on the first problem, I did that also. We're all human. So negative 1, 4, and then 0, 1, 2, negative 2, negative 3, negative 4, negative 14, negative 4, 2, 2, negative 4, negative 14. And this old boy is opening down based off my a value right here. So negative 1, 4, 0, 2, 1, negative 4, skinny guy. And the other point I can't necessarily plot. I need a dashed parabola because there's no equal to bar. And now read the symbol greater than, so go to the vertex and go above that. Greater than means above, meaning I'm going to shade in this region. So above means all of this stuff and anywhere outside the parabola. Like you're actually not inside the parabola. It's anywhere on the outside of that parabola. So lots of fun shading, 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 shading. Pretty simple, right? If it's in vertex form, you already know where the vertex is. If it's in standard form, you will need the x value of the vertex first. Sure, you could punch in your calculator, but it's so much easier if you find the x value of the vertex first. One dimension, because there's only one variable. Yep. One variable. They want to know when this guy right here, what graph will he make? Parabola. Tell me about him before we even get started. Open up or open down. Open up. They want to know when it is less than 0. Well, when something's less than 0 on the old, we always care about x because isn't that our variable right here, x? Tell me about, it's really the y situation. When it's less than 0, would you believe that all of this stuff down here is less than 0? And would you believe that all of this stuff here is greater than 0?
But where is this right here? Where is this actually at right there? That is 0, correct? So there's some situations that we have to deal with. We're always going to want to know how it relates to 0. Does it have an equal to bar? Does it not have an equal to bar? Is it greater than or less than? All of that kind of stuff. So let's solve this by the way the instructions say. It says, hey, if it's possible, man, factor this bad boy. Sometimes you can't factor them, but if it's possible, let's factor it. Because we want to find the zeros. Oh, the zeros? Don't we want to find when this is 0? And that's really where it crosses the old x-axis. The zeros, the roots, the solutions are the same thing. So we want to find those spots. Easiest way to do it is to factor. Then we'll sketch it and then figure out our answer. So let's see if we can factor this. Old school sheet is the a value 1. So see if you can find two numbers that multiply together to be -12 and add together to be. Find those numbers. What are those numbers? 2 and -6, correct? Since the a value is 1, we don't have to do the frowny face situation. We don't need the four-banger. It's super simple. X plus 2 as a quantity times x minus 6 as a quantity. Cool? And to make this make any sense, we need to change it to an equation. We want to know when that equals 0. To find the roots, you cannot have an inequality. We need it to be an equation. So we can use the zero product property. What two values of x would make this true to where x was equal to 0? The roots would be this. If x equaled what? -2 or 6. If x was -2, y would turn out to be 0. And if x was 6, y would turn out to be 0. So let's make a simple sketch of this situation. You can just freehand it. It's a simple sketch, freehand. X-axis, y-axis, nothing too large. And what we do is this is where our parabola crosses the x-axis. It crosses it at two different places. One place it crossed it at was at -2. -2. Just putting a rough sketch right there. Isn't this like pretty darn close to where -2 would be on the x-axis? Where's the other place that this thing crossed it at? Over here at 6 on the x-axis. Correct? Now what we're going to do is freehand sketch this parabola, and there's only one more thing you got to know. Does it open up or does it open down? Opens up. So this shouldn't happen, right? And if I actually went through that point, why shouldn't that happen? Because that opens down, correct? I want a parabola that opens up, and it better go through those 2 points. I don't care how pretty it looks. It just better go through those 2 points. Isn't that a simple sketch of this situation to where it's got roots at -2 and 6, and it opens up? Cool. Then they say, when is this thing less than 0? We got to go back and use our inequality symbol now. Well, check it out. When it's less than 0, it means where is it below the x-axis at? What do you think about all of that? Is all of that stuff less than 0? Because it's below the x-axis, correct? So they say, please write the answers in interval notation and in set builder notation. All you're reading now, my friends, is your x-axis. Maybe. Is your x-axis. Isn't this entire portion of the x-axis where that thing was? From -2 to 6, it was always below there, correct? So the question is, does -2 count and does 6 count? Aren't they on the x-axis? Do they count? Well, they'd have an equal to bar there if they did count. Do they count? So interval notation. When things don't count, do you use a parenthesis or a bracket? Parenthesis from -2 to 6. Isn't that our entire place when x is greater than -2 and less than 6, not inclusive? That's in interval notation. In set notation, it's the set of all x's such that. Smaller boundary on the left. What's our smaller boundary? Does he count? Symbol points to the left also after that. Does he count? Nope. So no equal to bar. Variable is x. Symbol points to the left. Did 6 count? Yes or no? Nope. Then 6 is our bigger boundary. Set of all x's such that x is less than 6 and at the same time greater than -2. In this zone where the x's were bigger than -2, because if you put this point right here, that's like 0, -3. Tell me about the x value. Is it between -2 and 6? Yes or no? What did the y value turn out to be? Greater than 0 or less than 0? Less than 0. Right here. That's 0. How about 1, -3? What a horrible idea. How about this guy? Isn't he at like 2, -2 or something like that? Just a rough idea. X value. Is he between -2 and 6? What's the y value? It's less than 0, correct? I picked this guy right here. That's at like 7, 1. X value is 7. Is the y value less than 0 at that place? No, it's 1. So in this spot was where that was less than 0. Let's try another one. Number 6. They want us to try to factor this guy. Is the a value 1? Nope. Is it a GCF you can pull out? Is it a perfect square trinomial? Is it a difference of squares? Frowny face. -6. Two numbers that multiply together to be -6 and add together to be 5. Tell me about the two numbers if they multiply together to be a negative. One of them is negative. So what are those two numbers? -1 and 6. This is a four-banger situation, correct? So first guy leads off, 2x squared. Then it doesn't matter what order you put those two in. The -1 should come first. It makes it easier. So what do we write next? -1x plus 6x. Then that -3 comes on down for the ride, and we're going to make them equal to 0, because that's what we're trying to find out first. Where is this thing actually equal to 0 at? Where does he cross the x-axis at is what we're finding. So let's double group. And pull out a GCF in each group. Okay, do it again.
Excuse the interruption, staff. We are experiencing.
If I get a 2x minus 1 in my first group, shouldn't I get a 2x minus 1 in my second group also? What's the GCF we're pulling out of the second group? 3 plus 3, right? Goody gumdrops? Yeah? Then what's the next move? Regroup to where the x plus 3 comes down and the 2x minus 1 is a common group. Then we solve them both. X could equal negative, or what's the other guy? 1/2. There's our roots right there, baby. Roots. So we plot them both on a simple sketch. Simple sketch. -3, way over yonder. 1/2, yeah, right here. It doesn't have to be the most perfectly accurate looking thing in the world. Parabola, though, you must decide open up or open down. Look back to your original. Look back to your original. Open up or open down. How do you know it opens up? Positive a value. So, there's my simple sketch. Now it's time to read the symbols again. They want to know when this is less than or even equal to 0. Less than means below the x-axis. So la 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 la. Isn't that below the x-axis? What does the equal to bar really include here? Means that these count and this counts, right? Where it actually touches the x-axis also counts. So let's put her in interval notation. Started here at -3. Did he count? So that's a bracket, right? And then went all the way to 1/2. Oops. And that's a bracket also, because doesn't the 1/2 count? Correct? Now put him in set notation. I'll start you out. Set of all x such that. -3. Got to have bars. Why do they have the bars? Because those points counted. Yes, sir, Bob. Next one. Go for him. Try to factor. Pause the video. Please factor him, and then we'll meet back. Because this guy's sign is negative, you must factor out a negative GCF in this situation. And then you use the zero product property to find your roots. So there's my roots. This puppy opens up due to the positive A value. Correct? I would like you to put these, I forgot to tell you, but then let's put some dark squiggles. There's just some squiggles of we're going to do this like I was doing before. So they say this is supposed to be greater than or equal to 0. What does that mean to you? Above or below the x-axis greater than 0? Above. What do you think about this guy? Is he above the x-axis? And this guy, isn't he? So just squiggle over them. They don't have to be very dark, but just squiggle so you can see what's going on. The question is, do these actual roots of 3/2 and 4 count or not count? They count due to the equal to bar. So holy macaroni, isn't there like 2 different intervals that we shaded, as opposed to previous, there was only 1 interval where we shaded, correct? 1 spot with shade, 2 spots. So let's read it in interval notation. How far would that keep going? To negative infinity, correct? Which always has a parenthesis, comma, and then doesn't it just keep on happening up to 3/2? Did 3/2 count or not count? What? Counts. Then what do you put right here? Union. 4 is next. Does 4 count or not count? To how far? Now, let me explain that for those of you that got a cringed eyebrow. We're talking about x values, correct? X values. So here's my highlighter. X values. Where in all the x values, if you pick the point on there, isn't the x value come down to this spot? Doesn't the x value come down to this spot? Doesn't the x value come down to this spot? How far would the x values reach in this situation? To negative infinity, all the way up to 3/2 included. Then the x values went this way also. It was in this spot to where that didn't happen. Cool? So that's why that is this. In set notation, set of all x's, such that. Explain this one to me. What does it look like to you? X is what? Less than or equal to 3/2. Word is or, because it's a union, which is a or. Remember, disunion greater than or situation. Figure out the other interval. I gave you x is less than or equal to 3/2. What does this really mean? X is greater than or equal to 4. Correct? So far, so good? Next, try to factor him. Is the A value 1? So I'm trying to find 2 numbers that multiply together to be 5 and add together to be a -4. Well, my multiples of 5 are 1 and 5, or -1 and -5. Correct? Do either of those add to 4? What do you think? So here's what we write. Off to the side, not factorable. Does that mean we can't solve it? It means we can't factor it. Can we solve it? You bet. What are our other options? Complete the square, or what else? Quadratic formula. Well, complete the square is pretty simple. Sometimes it's pretty difficult some other times. Is this a simple complete the square situation? Is the A value 1? Is the B value even? Let's complete the square on this puppy. Remember, we're keeping them as an equation. So x squared minus 4x plus blank equals -5 plus blank. What? Why did I put plus blanks both times instead of plus blank and a minus blank? They're on different sides of the equal sign. If you add 7 to one side, you better add 7 to the other side to keep it balanced. If you're on the same side, you got to do kind of like the opposite ideas. Fill in das blank. What goes in das blank? 4. Awesome. So this guy, I know he factors right here to be x minus 2 quantity squared. Everyone down with that? Over here, this will tell you everything you need to know. Negative 5 plus 4. So negative 1. And isn't the next move the square root? Right? Isn't the next move the square root? The square root of negative 1? Sure, you can go to imagination land. But what does that tell you about where this parabola crosses the x-axis at? It does not cross the x-axis. So here's what we will write. Because this is a negative number, no real roots. That still doesn't mean jack squat about this answer, because we could either have no solutions or infinite solutions, because it depends on where that parabola is. You know, that parabola could be up here, or that parabola could be down here somewhere. Doesn't it have 2 spots to where it could be in relation to the x-axis, above it or below it, correct? So we have to figure out where the vertex of this parabola is. We have to figure out where the vertex of this parabola is. We have to figure out where the vertex of this parabola is. Did we complete the square on this guy already? So it's pretty darn close to vertex form already. This quadratic is pretty darn close to vertex form already. If this was over here, wouldn't that be in vertex form? So you can think of it as the vertex. Here's your x value situation. What is really the x value of your vertex? 2. And this guy's got to come over here, though, right, to truly be in vertex form, correct? So if he came over here, wouldn't it be a plus 1? And don't you just read him the way it normally is over there anyway? So what's our vertex at? So vertex is at 2, 1. So let's kind of roughly sketch him. 2, 1. There's my vertex. How does this parabola open? Up or down? Opens which way? Up. That's all I need to see. Now I can answer this question. The thing goes back to this. When was that parabola less than 0? Did it always happen or never happen? It never happened. So what is our answer in this situation? No solutions. So in interval notation, that's this. That's what it is in interval notation. In set notation, what would you put in the set brackets? Nothing. What are both of those symbols called? Empty set. Because what's in the set? Nothing. What's in this? That's an empty set. Does every one of these answers turn out to be empty set, though? Now, what if this was a greater than symbol? Wouldn't this always be greater than 0? So then that's all real solutions, right? From negative infinity to positive infinity kind of thing. Cool? Next, let's skip number 9 and go to skip number 10 even for some reason. Let's go to number 10, though. I got to get him back. So start working on number 10. What's the problem with number 10? Let me just rewrite him here since I don't have him. 0 less than 6x minus x squared minus 5. What's the problem with number 10? What don't you like about him? I think the 0 is on the wrong side, personally. And over here, do you like that order? No. I really, when it's in x squared first, b second, and c third, right? So let's do this. Let's put him in the right order. Negative x squared plus 6x minus 5. I just rearrange those, correct? And 0, I did that wrong. Let's do this a little bit better. My bad. Let's just move all this stuff over to the right side and move all that other stuff over to the left side. If this guy comes over, what would he turn into? I'm going to add him to the other side. X squared. Then what would you get next? Minus 6x plus 5. And then that guy, the symbol did not change or anything like that. We all cool with that? I added this over, added this over, added this over, added that over. Yes? No? Maybe? Algebra 1, moving stuff from one side of the equal sign to the other, or one side of the inequality to the other. All good with that? Yeah? Try to factor him. So, -1, -5, right? So, x minus 1, x plus... How come that one was minus 5? How come that was so simple to factor? I didn't have to go through that whole mess of stuff. A value is 1, all right? Where's my roots at then? X equals 1 and 5, correct? Those are our roots. 1 and 5. How does this parabola open, up or down? Well, we better look back to the original guy. All right, we better look back to the original guy. We changed him around a little bit, didn't we? We better look back to the original guy. Does he open up or does he open down? This is the wrong, I crossed out the wrong, that was the wrong problem. The original guy was 0 less than 6x minus x squared minus 5. How does that guy open, up or down? It opens down. Why does he open down? The a value is negative. And it's like, but we made him positive over here. Sure, we made him positive, but you have to always look back to the original guy. Even if it opens up or opens down, would you believe that the parabola will cross the x-axis at the same place? Right? If it opens up, opens down, it'll always have the same roots. This guy opens down, my friends. Opens down. That's the trickiest part about these that are not in standard form already. You must go back to the original problem and realize that he opened down. Now figure out where this thing is. Whoa, what does that even say? Does that say greater than 0 or less than 0? What does that even say? It says greater than 0, doesn't it? We got to figure out where he's greater than 0, which I believe is right there. So in interval notation, only one interval. Yeah. And in set notation, it's a set of all x's such that, how come there's no equal to bars or no brackets in these situations? We didn't have an equal to bar over here. Tricky, tricky, tricky. Just like this one. Tricky, tricky, tricky. First, is 0 on one side of this symbol? Yes or no? So let's get him on one side of this symbol. Correct? Correct? Let's factor him. Is the a value 1? This is the c value, correct? Meaning, I need two numbers that multiply together to be 8 and add together to be 0, correct? Well, then numbers that multiply together to be 8 are 1 and 8, or they're negatives, 2 and 4, or they're negatives. Do any of those cases add up to be 0? So that means that this is not factorable, correct? It's not factorable. Cool? What I'd like you and your neighbor to do is to look back to this original problem and discuss it with common sense. Let me give you the question, I guess. The question is, when will x squared be greater than negative 8? That's the question. When will x squared be greater than negative 8? So here's what I'll do. Make up an x value. 1. What's 1 squared? Is it greater than negative 8? 10. 10 squared. Is it greater than negative 8? How about negative 7? What's negative 7 squared? Is it greater than negative 8? When will x squared be greater than negative 8? Because when you square something, what does that mean it turns out to be? And will a positive number always be greater than negative 8? So I already know how many answers there are to this. There's an infinite amount of answers, correct? I know there's all real solutions. They need a simple sketch of this guy, though. He's in vertex form already. If you thought of it like this, my bad, x squared plus 8 equals y instead of like equals 0, and you switched them around, y equals x squared plus 8, that's in vertex form. It's the same thing as saying y equals x plus 0 squared plus 8. What's the x value of the vertex? What's the x value of the vertex? What's the y value of the vertex? Isn't this just a normal old parabola? The standard parent function shifted up 8 units. So, boot, opens up also, correct? When is that thing greater than 0? Isn't that what this one says right here? When is that thing greater than 0? Never or always? So in interval notation, that's from negative infinity to positive infinity. In set notation, it's a set of all x's such that x is, what do we want to write next? An element of the reals. Common sense did that before I even got started. I looked at it and said, oh, that's all real solutions right there. They want a sketch. If you want to go to no work shown on something like that, I'm down with it. But I also need a sketch of that because that's part of the instructions. So like, go ahead and figure this out, make a simple sketch, then write it in both notations. Let's jump down to here. Write a quadratic inequality for the graph to the right. You already have it. You already see where it's shaded. We want that equation slash inequality in vertex form. Can we do that? Do you know where the vertex is? Do you know any points on this? So let's do a little vertex. Is at 1, 7. And a point, we'll just call that PT. Pick a point, any point. Which point do you want? Who cares? 0, 6 would be fine. People saw the 0, they're like, Daddy likes 0. Any of those points would work. It would all get you where you want to go, right? Then we'll HKXY. Remember, the vertex is HK. The point is XY. Put a little y equals A times quantity of x minus h squared plus k. Substitute in, find A. Then we're in business. 6 equals A. X is 0. Ooh, neato. Plus K. Should you get a negative value for A? Yes or no? How do you know before you get started you should have got a negative value for A? It opens down. Everyone with me there? But we're not done. We need to write this as an inequality. Do we know the A value? Cool. So it starts with y, but we won't have an equal sign anywhere. We need an inequality symbol. Where is this guy shaded? Above the parabola or below the parabola? So what symbol do you want? Less than. Do I need an equal to bar or not an equal to bar? How do you know you need an equal to bar? Solid parabola. Then the rest is negative 1 times the quantity of x minus 1 squared plus 7. Done. You down with that?